Welcome to my talk, which is adding event sourcing to an existing PHP project for the right reason. That is the important part. First and foremost, who am I? I'm Alessandro Lai. I'm a project lead at phpd.it. We are a Milan-based company. We do mainly comparison of financial and insurance products. Those are my handles, and I'm also one of the coordinators of the user group in Milan for PHP, and the secretary for the PHP FIG. And please come back me after the talk if you want to talk to me, because, well, yes, we are hiring. Yes, we are interested if you want to host one of our meetups in Milan. And we are even more interested if you want to do a talk. And I highly encourage you to do that, even in your local user groups. I, for example, did a test of this talk there. And we'll be doing a meetup for the PHP FIG in the afternoon in the unconference talk. So join us if you're interested in what we are doing. If this is enough of a reason to bug me, I have stickers, so come and steal it from me. So before going into the main topic, I want to say some things before. Well, for starter, this is a case history. It's not theory, so we'll be seeing maybe code. We will be seeing examples and practical issues that we had in our implementation. So we'll just do a brief scheme on the theory at the start. And we also bent the state of the art in some places, and I will be saying that to you where and why. And I want to do a disclaimer also, and two disclaimers to be truthful. And since we are programmers, this is disclaimer 0. And it's not something that I did by myself. It's a group effort. It's done by a team. It was my team up until last summer, where we did this project with event sourcing. I'm now leading a different team, but still I wanted to find the time to talk about this argument because I think it's really important. It's an interesting topic. And also, second disclaimer, we didn't even do all by ourselves. We asked for help. As Gemma said yesterday in the keynote, it's important to call professional when we are out of our depth. And we asked help to Gabriele Lana, which is a very good consultant, which is probably well known around here, because we needed a speedy bootstrap with both MongoDB and event sourcing. So first thing first, what is event sourcing? Okay, normally we skip the part about theory because it's lengthy and it's not so interesting, and we use an example. The main example in this case is money. Why money? Well, because I wanted to steal it from Fabian. No, it's not true. In reality, he stole it from me because I did it before. But the main reason is that you can trace back something like event sourcing to older stuff, like invention of the banks in the 12th century. Because when you have to handle money, you have to do it securely. You have to be sure that you're not misplacing, you're not spending twice, as he said before. So let's try to make an example with PHP, with an application. So if you want to have transaction, you have a bank, you want to have money accounts, and you don't want to use events, basically you have to save the current state of your application, so the balance, how much money do you have in your account. And this feels a bit strange because basically each time that your application does something to your account, it completely writes the information. So you have 1,000 euros, then you withdraw 100, and you have 900, and so on. But what about concurrency? Okay. With the blockchain, you've said that you have to do a lot of stuff to avoid these kind of issues. Well, if you have something without any possible solution, like a complex one like blockchain or events, basically, if you have two operations at the same time, the second will get lost. And in our applications, we are basically addicted to software transactions, so we use the DBMS to avoid issues. And the DBMS just says, okay, if I have two concurrent transactions, I'll make the second wait or make it fail. So it's just a workaround. It's not a proper solution. When you use events instead, basically you store performed actions. So I withdraw or I deposit money. And in this way, concurrency is no longer a big issue. because basically the only issue is that you may go in the negative, so go below 0 in your account, but it may not even be a problem, because at this point you can, sorry, this is not, you can, for example, ask your domain expert, to your business, if you want to allow your clients to go below 0, and maybe ask them to pay additional fees for that. So you've transformed something that was a technical issue in a predicted behavior, in something that you code against. And even if you have just events, you're still able to have the balance. You just have to aggregate all the events. For example, in this example, you just have to sum all the transactions. So it's just a plus operation. Obviously, when you have a complex application, it's just not simply numbers. You will have a lot more, but it's still an aggregation. You just have to read all the events and say what that means. The other theoretical stuff that we have to know is CQRS. It's obviously an acronym, and it stands for Common Query Responsibility Segregation. And it's normally opposed to CRUD. And I will not go there. There's a really good Martin Fowler's article about that. And don't worry, the slides are linked in the joined in, so you can get that later. And what it means is basically that with CRUD, you have basically the same piece of code to access the state of your application. So let's take, for example, a doctrine entity, okay? You have the same class that maps to your table, and you use it to read from the table and to write it down. In CQRS, instead, you have two splitted pieces of code. So you have a command that is the write part. So you tell your application to do something and change the actual state. And you have the query part, which is read part. Basically, you're just querying the state of your application and getting some information back. OK, that's enough for the theory. Now I want to justify why I wanted to do this talk, OK? Because there are a lot of talks and blog posts and tutorials about this. But I think that we needed to cover a small portion of this argument. I want to use a story to justify that. Let's say that a long time ago, in a galaxy far, far away, you were coding at your computer, and your boss came to you and says, OK, now you have to start a new project. You will have to do a lot of stuff. You will be adding this feature and those users and blah, 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 blah. And you start writing down all your requirements, and you say to yourself, OK, great, it's big, it's complex. I have to start from scratch. I will be doing a lot of tests and code coverage and so on. And I have enough stuff to justify using event sourcing. So basically, you will have a greenfield project, right? You will start from scratch, and you can add everything you want, all the shiny stuff. But let's be truthful. This is science fiction, right? This doesn't happen a lot in our job. Normally, you don't work with something that looks like that, but with something that looks like this, OK, right? So you have legacy code, you have to refactor, you have to fix bugs, you have to add new feature at the same time, let alone have time to add something so complex as event sourcing, because it's something that has some inherent complexity. So basically, in the real world, even if you have to start a new projects start small and simple. You have a prototype, a few features, and that's all. So adding event sourcing from the start is costly because you have to add a lot of infrastructure. In PHP, we use a lot CRUD because it's really fast. You get something out of the door so fast that you can prove your idea and see if the customer responds to that, and then later evolve the prototype in something more meaningful. So the inherent business complexity comes only with time when you start adding new feature and new stuff start interacting. So you have enough of a reason to use something so complex only later on. And this is something that I think is not well covered with what I found in videos and blog posts and so on. So in our case, I will give you a bit of a background on our project where we needed to do that. Our use case, basically, it's the project of the Shark team, which is the one that I showed you before. And it's called FPN, Facile Partner Network. It's basically a platform, a business-to-business platform that it's used to sell insurances, car insurances. The difference between that and our public site, it's basically that we offer this platform as private to basically agents around the country. The dear old agent with his physical office that normally just sells insurances from all the companies. With us, is able to sell insurances from the online companies, the direct companies. Okay, so maybe it's cheaper, they have more options, and so on. So the issue is that all of this is complex because first we have to handle the product after it's sold. When you go to our public site, you can buy car insurances, but you will be doing that by yourself, and that's all. But if you do that in our platform, we will be handling after it's sold all the documents, so the customer relationships. We have to be an adapter for all the insurance companies. I mean adapter in the sense of the design pattern. So basically, the agent doesn't have any difference in our platform if they buying from a different company, even if the company has a different process to handle. For example, I don't know, if you have an accident and they have to pay you back and stuff like that. And last but not least, we have a big backend with more than 40 people working on it. The project is more than 6 years old. It went through a lot of migration, then first Symfony 1, then 2, now it's on 3, new stuff, and blah, blah. So we reached the point where we had really a business which is complex, that can justify using something so complex. But our main issue, what we wanted to solve with event sourcing, was that we had a business that was evolving really fast. And we started growing, and we needed to give our business analysts new data to work on, numbers that they had to crunch to give us information, how to evolve even further. But those reports are tricky, because maybe someone asked for a report in January, and after that, we had to give them historical data. So if we had to do a refactor and change the table underneath, basically the data from January shouldn't change, okay? So we had these big SQL queries that were basically a dead weight. Every time that we needed to develop a new feature, if we had an SQL query on that tables, that was an issue. That was something that we couldn't change, or we were forced to change and not make the behavior change. Also, we had a small piece of functionality that we knew that we had to migrate out of our relational database, basically MySQL plus Doctrine, because it was having too much Doctrine hierarchy in there. So basically, we knew that we needed to call for help, add MongoDB to our tech stack, and start doing event sourcing. So let's dive into the practice of that. Okay. Basically, what is an event in our system? Okay, it's just a document in our MongoDB database, and it has just 4 properties. So we have type, family, payload, and metadata. So for those of you that never seen a MongoDB document, it looks a lot like this. It's basically JSON, but they call it BSON because it's binary to store it easier. But we have basically type and event family as 2 strings, and those are used to, well, the type is the event name, so it says what document you have in front of you, and it's used to know what field to expect in there. And the family is more of a grouping. So for example, the type can be payment received, product sold, user created, and mind you, the name must be in the past, because they haven't just happened in your application. The family may be something like the payment family, the product family, the account family. Okay, it's just a grouping to know the generic meaning of the event. And both are really useful to searching and filtering through the events, because you have to store all the events in a single collection all together, because you never know how you will want to mix them. And you will basically never work with all the events at the same time. You normally concentrate on a bunch of types or a single family. Metadata is not a string. It's a group of data. It's obviously, as it said itself, data about data. And we use it for search purposes too. And the most important subfield in metadata is created at. Basically, it's just the timestamp when the event has happened in the past. And we needed an index in there, because obviously you need to go through the events in an ordered fashion. And we also use it to store system information. So you can have the user which was logged in when that happened, the origin, which server, IP, if it came from an Android application or something else, and blah, blah, whatever you want. The payload instead still not a string, still a group of data. It's the core of the event, so the information about what happened, the event itself. And remember, as I said before, the event it's already happened, just happened, because that's the exact moment where you have all the information that you need at hand to write them down. And at this point, maybe you can ask yourself, I don't know, should I put this information in there or not? It's too much? I'm missing something? And when we tried to ask this to Gabriele, basically he gave us this tip. When in doubt, do not omit. For one single reason. When you're writing down the event, you're just in the moment where that's happening, so you have all the information at hand. Later, maybe you can leave something behind. You can rewrite something on your database. So maybe you don't have all the information that you need. And instead, events should be written down and be immutable. You shouldn't change them later, because that's your ledger. That's your absolute truth. So how do you write down these things? Basically, for us, it was kind of easier because we already used a different kind of event in our application, which is the event dispatcher, which is a different thing, remember. Basically, we had a lot of business logic, which was already driven by events and listeners and subscribers here and there. So we already knew easily that there were a lot of spots where we needed to generate events. I can assure you that when you go down to look at your code, at your application, and try to decide where you need to generate an event, you will find a lot of places, even if your application is small. And to do that, we had the base event, which basically was just a class with a document for the MongoDB database with a few generic fields, plus decorators. A decorator is just a class that is able to add information about one kind of stuff. So we had a product decorator that adds information about the product, an account decorator, a user decorator, a payment decorator, and so on. And this is useful because since we are on a schemaless database, we wanted some code to keep something in order. So we have some consistency in fields, field names, and so on. At this point, we had a bit of a confidence issue because MongoDB was a new technology in our stack. Nobody on the team worked in the past on that. So we did one of the bending of the state of the art. Instead of storing them immediately, we decided to postpone that, to push the events into our RabbitMQ queue and do it later. Basically because you have to generate events everywhere, especially in critical paths. So for example, in payments and so on. And we wanted to avoid crash and bugs in those critical paths. We weren't so sure that maybe a stupid bug could make all the payments crash and lose a lot of money. So we basically prepared the JSON in real time while doing the stuff. Then the JSON was sent to RabbitMQ and stored later. So even if we had the bug, it was later and desynchronized, and we could fix that later. The problem with that is that we are away from the theory, because normally you should store the events in an immutable and order-in-time fashion. And when you push this stuff into a queue, you may lose the order. You can have multiple consumers that maybe do the write down at the same time, and maybe one comes first and the other second. And that's an issue, because you have to read events in an ordered fashion. So we did this exception as an intentional trade-off in our case. And that was also useful to us for another reason, because we needed immediately events from the past. And that's another thing that in theory you shouldn't do, because still, if you're writing for the past, that's not just happened, and you may not have all the information, all the right information. Because, for example, you're basically doing a derivation for, in our case, from our MySQL database. But maybe since that haven't happened, we deleted something, or we wrote something, we changed something in the rows, and stuff like that. So this trade-off was needed basically because, well, we sell insurances, so we handle renewals too, and a renewal is 1 year later. So if we wanted to do a report about renewals, we had to wait a year to have all the events about it. So yeah, not feasible for us. The only thing that we needed to do was avoiding writing duplicates. Basically, we started writing events in the present in real time, and then we started a command that started writing from the past and went in an order fashions on our database. When we reached the point in the present where we started doing that in real time, we had to check if that event was already present in the collection. You have just to be careful about that, and about, as I said, about the fact that you are deriving events from a current lossy state. So we had to do a lot of assumption, but that was kind of easy because the assumptions were based on our application, our business logic. So sometimes we were forced to do, well, let's say some rounding or some guessing, some guesswork, because we didn't have all the information at hand that we wanted to store. So with that, we have completed the writing part, and it's time to read. Okay, CQRS, as I said before. So you have to just have the data. At this point, you have all the data that you need. So how do you read events? Okay, before I said that you need to aggregate them. To do that, in reality, you have to do a projection. So basically, you replay the history. You go through all your events one at a time in an ordered fashion. So you're basically doing a time machine, let's say. And you use all the data to reconstruct the current state in a fashion that it's more useful to you. Maybe the normalization, maybe you switch the viewpoint, maybe you aggregate a field and not another, maybe you aggregate by user or by company or whatever. You don't have any limitation in that. And our implementation, it's like that. It's in 3 steps. We have a runner and a run state. We have a projector plus executors and a projection state. So let's dig into the code. So the one and only runner is just something that executes the projector. So it's just a class with one single public function, which is obviously run, and it gets a single argument, the projector. So this class is able to handle the cycle, go through all the events, and it gets the filters that it needs from the projector, and is able to iterate easily. And obviously, since the collection of all the events is really big, I'm talking about millions of documents, you have to handle, obviously, the memory stuff and all these things that you normally do in a long process in PHP. The run state, instead, is a document. Obviously, we map that to a class, but we use a Mongo document interface to say that this class is serializable and deserializable to the database. And you have one run state per each projector. So you have the class name in there to identify. Obviously, we have a unique index in there for that field. And you have a still running Boolean flag, which is basically used to say, OK, the projector is running right now or not. And the timestamp, last run at, that says, OK, this is the last time that the projector ran successfully. Afterwards, you have 2 fields to remember which was the last event that went through all this stuff. We need 2 fields and not just one because we have those out-of-order events. IDs in MongoDB are ordered in time, so we need that and the timestamp, the created that timestamp from the event. We have to check both of them to be sure that we are not out of order. The projector instead has an interface. It's kind of easy. Basically, we have 3 methods that are dedicated to do the processing of data. So we have a pre-hook, a projection save, which gets the event and does something, and a post-hook. Okay? And also the 2 methods that are needed for the filtering. So a get event types that gets a string of an array of strings of the types of events that you're interested for that projector, and an additional filter getter that is used if you want, for example, maybe you have a report that it's meaningful only from this year forward, so you can exclude all the older events, so you will get a faster projector in that way. Let's see the code implementation. Okay, this is the run method. Basically, this is the first half, and I can assure you that this is pretty much the actual code. I've just hidden maybe 1 or 2 lines behind fake private methods, but this is the actual implementation. Okay, in the first half, we do just a few checks. So first thing first, we get the run state from the database, and we check the Boolean flag. We check if the projector is still running. If that is true, we have a problem, because that means that the last time that we executed this projector, it crashed. So we have an inconsistent state in our projection. In this case, we decided it was better to clean the slate and start from scratch. Because basically, trying to handle inconsistent state there, it's really, really hard. You will have to write a lot of logic and stuff to handle that, and it doesn't work. It's not worth it. So it's a lot easier to say, OK, let's start from scratch and concentrate our effort in optimizing the projector so it's faster. So we don't have to bother about the fact that we have to start from scratch. At this point, I think we've reached 3 million events in our collection, and all the projectors are able to start from scratch in maybe 5 minutes. So it's not so much for processing all of this data at once. And so afterwards, we can do the actual query and get an iterator, which in MongoDB, it's a cursor, but well, it's the same thing as fetching 1 row at a time from MySQL. Obviously, we pass through the projector and the run state to all the information. And we check obviously, if the cursor is empty. If it's empty, that means that since the last time that we ran the projector, we didn't add any new events, so we don't have to do anything, and that's all. We just update the timestamp on the run state, and that's all. If we have some events to process, we get the first, and we do the one last check, which is the first event, which is obviously the oldest between all the one that needs to be processed. It is older than the last one that we got in the last run. If that is true, it's another inconsistency, because that means that we got the events out of order too. This is another inconsistency, so this is another place where we chose to reset and start from scratch. This doesn't happen so often. Normally it happens because we wrote some new events in the past. And after 1 year that we are running this stuff, it doesn't happen anymore, basically. Because if we had new features, normally we start writing events right from the start, and that's all. So we prepare the run state to say, OK, switch the flag to true. We are running. Let's go. Green light. OK, the other half of the method is this one, basically a cycle. You have to go through all the events, pass them through the projector, and that's all. I've added this if. Basically, we are able to stop the projector gracefully, because if a single event got processed, we can do it gracefully. And I will explain later why this is useful. So when we are done, in either case, we just call the post hook, because maybe you need, I don't know, to clean some stuff up, or maybe you have some holes in your projection. For example, maybe we had a case where we wanted to count how much stuff we sold each day. And obviously, we had holes for Saturday and Sundays. So we just needed to put a 0 in there to have a consistent amount of data without to have to post-process them later when feed it into maybe, I don't know, a JS library for a chart or stuff like that. And when we are done, we update the run state and say, OK, we completed successfully, shut the flag to false, update the last run at, and that's all. So obviously, all the logic is in there, in the projector, right? Nope. The projector in reality is just a small container. And we delegate all the hard work to executors. Basically, we had executors to the projector, and each executor is able to handle one type of event, which is pretty useful. Well, in the interface, we return an array to say which event we support, basically because We had some cases where we had similar events that could be handled in the same way. For example, we had two different events when we were selling an insurance and a renewal of an insurance, but it's the same basically. So they had a lot of fields in common, so many times you could ignore that. And obviously we have an execute, which gets the event and goes forward. So the core, it's in those executors, and those executors have a strong requirement. They have to be idempotent. So if, because there's a bug or something like that, an executor gets an event twice, we have to be sure that it's not a problem. Okay. For example, you can get, I don't know, twice the event product sold. Okay. You may have a bug in your application in the point where you generate the event, or maybe since we generated the event from the past, we did some mistake and stuff like that. To do that, we use the projection state. Basically, you can have, well, the projection state is still a document in MongoDB, but compared to the run state, you can have as many projection state by projector as you want. So you still have the private class, but no unique index. And you have a correlation ID. A correlation ID, well, you can think about it like a cache key, okay? So for example, as I said, you have two events for a product. Probably the correlation ID is the ID of the product, okay? So you can search for the projection state for that product and see if you have any data in there, anything useful. So for example, I can store it there the moment where the product got sold. So when I run the second time the executor, it checks for projection state. It does find one that says, okay, that this product is already sold. Okay, I don't have to do anything else. It's already covered. Or maybe it doesn't make sense. I don't know. You have to pick what you will have to do with that event. It depends a lot on your business logic. Also, you have an expire that field. Why? Because this collection of projection state is queried once for each event. So if you can optimize there, the projector will be a lot faster. So sometimes we've found that you can even make a state expire. For example, since an insurance is 1 year long, after that year, we do not care anymore about that. And even the absence of a projection state is an information. So if you're trying to see if that product is sold and you do not find the state, well, it's not sold. So it's easier and it's faster as a query. We use this index in MongoDB that basically says that when the timestamp is over, it auto-deletes the document. It's really useful. So you have just to store the bare minimum data in there to be fast. So this is all for the implementation, okay? It's not so complex. But the point is that we got something really tricky in there, and Gabriele gave us that. Basically, the trick, I think, is pushing the state away. All the classes that I told you about right now doesn't have any state. The runner, the projector, and the executor don't have any properties that are not dependencies. All the state, every time that you need to write down data, we push them away from our architecture and into a service which is designed to hold state, a database. In this case, still MongoDB, okay? And that's pretty useful because that means that the architecture works really well. Obviously, we still had some issues in there. The main issue, as I said before, is obviously that you will start having a lot of events because you will just add and add and add new events every day. And this means, obviously, that the projection can take a long time to complete. And as many of you may know, long-running processes are not so good with PHP. So we had issues because one time we tried to force the garbage collection to reduce the memory consumption, but we discovered it was even worse than before, so we stopped doing that. And another time we found a memory leak in the extension of MongoDB, which is bad because we couldn't fix it ourselves. We had to wait. And what we could do in the meantime? Well, we decided to shorten the execution of the runner. This is why in the cycle, in the runner, I've added that if. Basically, we used a stupid solution that works. We use crons, maybe every 15 minutes, and the runner decides to stop gracefully every 14 minutes and something. Okay, it's a stupid solution, but it works. And that means that we run the runner in short bursts, and we are sure that memory leaks are not so a problem for us. Obviously, we had to add a lock, so we used the Symfony lockable trait to check if a runner was still running because maybe, I don't know, we did some mistake, or the previous one needed to start from scratch, so it took longer than needed, and so on. But still, it's a stupid solution that works. We are changing something in our architecture, but this is enough for now. The other problem that we had was updating past events. It's another thing that you shouldn't do because, as I said, events should be immutable. You shouldn't change them. But especially from the start, we found some issues because, wow, we were inexperienced. And so we found, oh, we forgot to add an information crop. But since we did that trade-off from the start, the fix was easier. We just needed to fix the code that wrote down the events, fix the events, so we basically deleted them and rewrote them from the start in the past, and reset the projection. Obviously, we had to avoid report outages because in the meantime, obviously, data was not being completed at runtime, and we had to take a snapshot of the projected data. So another issue also was code reuse. Especially for me, I was tempted many times to reuse an executor between different projectors. And you shouldn't do that. I was tempted because the executor, if they work on the same events, they look a lot alike between them. Okay, so you think, oh, dry principle, do not repeat yourself. Well, it's not like that. Because yes, they're similar, but they're working something different, in a different context, in a different projection. So this is one of the cases where copy and paste is better. Okay. Otherwise, you're coupling stuff that doesn't belong together. But obviously, it's not so bleak. We obviously gain something out of it. Well, to start, we reached our goal. So we were able to obtain reports that were not so hard to develop and to maintain. And it was really easier to read in the data because we were just reading, going through the time. So we were able to handle one event at a time. Okay, this happened, so this. Okay, this other thing happened, so that, and so on. And those reports were obviously reliable because we just needed to handle for new events maybe in the future. But you can do that one step at a time with code and not with some gigantic SQL query that gets slower and slower over time. We also added MongoDB to our tech stack, which is cool. You learn a new technology. And we discovered that we could reuse projection. Why? Well, a projection can be anything you want, okay? I didn't show you anything inside the executor because inside they could do anything. In our case, many times they wrote down on MongoDB, still on MongoDB, without any schema, what you want. But if you, I don't know, maybe you have a table for a report which is too slow and too complicated, you can use the executors to rewrite that table. Or you can write down in a JSON, in a text file, whatever you want. You have no limit in there. You can produce something that represents the state of your application without no limit. In our case, we decided to reuse that. So we had events, we have projector, and we have a projection. But for us, the projection may be an intermediate solution. Okay, for example, we have a projection that just is a denormalization of all the product that we sold. Okay, in a nice way that is then afterwards easily queryable with an aggregation in MongoDB. This means that from that single projection, I'm able to have multiple final results that afterwards we can snapshot. So we have an aggregation that says, okay, we are aggregating by user, then by insurance company, by week, by month. You don't care. you have denormalized the information in an easily queryable way. You don't have a table which is designed to handle your business logic. Okay, so we had our application that was leveraging a lot transaction from MySQL, and we didn't want to bother that and shape that just to make our report easier through SQL. We did something different that is dedicated, so it's obviously more performant in doing that task. Another interesting thing is the architecture. This is a scheme of what I've told you. Okay, you have one single runner, multiple projectors, and then multiple executors for the single projector. Okay, this means that we push the complexity down and splitted it across all the executors. So at the end of it, mainly an executor is 5 to 10 lines of code. It's really small, so it's really easy to unit test them. And afterwards, you just need an integration test with only the projector and the executor. You have a single test that says, OK, I have a data provider with a stream of events in, and I expect this exact result. So every time that you find a bug, you just have to say, OK, if I have those events, I expect this stuff. And if there are some mismatch, you know where to debug. It's really easy, really fast, because you may reduce the reproducing case of the bug to a really small group of events, maybe 10, maybe 5, maybe 20. It's something that you can handle easily. Also, with the event collection, we gain debug superpowers. Why? Because basically, we knew everything. We were omnipotent over our application. We knew that in the past happened this, this, and that. So when we got a bug report, which was a little strange, we were unable to reproduce it. We just went to the event source, do a small query, and said, OK, this product, the user did this, this, and that. And so we were able either to have a reproducible case for the bug, or says to the product owner, well, your user did something that was not predictable or wrong or something like that. Last but not least, we did some open source out of that. We did a Symfony bundle that basically it's an integration with MongoDB. We choose to use the new extension from MongoDB. It's XMongoDB. The older, I think it's XMongo. And this bundle gives you access through the dependency injection container to the database and the collections, and also gives you a nice profiler add-on. It's a page that looks a lot like the Doctrine one. So you have all the queries, time of execution, explain, and everything. So that's all. Thank you.